Good afternoon, everyone, and welcome to this week's 30 at 3 Live. This week we are going to focus on shear plate connections. Thought it'd be a good idea to get everybody familiar with different setup options that we have that are going to affect our shear plate design. And just some different things that we can edit as far as our shear plates go to give us different configurations and achieve different types of shear plate connections. So first thing I want to look at then, it's important for everyone to know and configure their setup options that are going to affect how your shear plate connections are actually designed. So first thing I want to do today is look in our setup, and there is quite a bit of stuff to cover here today, so if we end up going over the 30 minutes that we say, it's no big deal. If anybody's got to skip out, that's fine. My feelings aren't going to be hurt, so hopefully we'll be able to get it done. I know everybody's busy, so just a little heads up there. So first thing then in our setup, remember that our auto standard connections, those can all be set to use our shear plates. So if we need to configure that to use shear plates, and then we have all of our different connection specifications that we can set to achieve the correct connection for us that we want. These are also going to be, we'll see these in the connection edit screen here in a little bit, and we'll go over and kind of talk about each one of those options there. Just want to show you, you can set those up to be used with your auto standard connections. In the schedule of minimums then, notice we have two tabs under this section. We have a tab in here for schedule of minimums for our single plate shear connections. So this table is going to determine the minimum, or it's kind of a starting point or a minimum for SDS to connect to begin designing these connections. So we have the minimum bolt diameter we want to be used for our shear plates, the minimum thickness of those plates, and then the minimum number of rows of bolts we want to use. So keep in mind this really is just a starting point for SDS to connect to design the connection, and then as it goes through its design routines, it may increase the bolt diameter, the plate thickness, number of rows of bolts, depending on what loads we may have applied and whatnot there. You also notice over on the left here we have the nominal depth, so that is setting the nominal depth of our beam, and we can have these minimums set differently for each nominal depth that we have set here. Okay. Next, in our field clearance information, we have a field here for our shear plates. So this is going to determine the field clearance, which would be the distance from the supporting member to the end of the supported member when the connection type is set to shear. Okay. If our connection type is set to auto standard, remember there is a field clearance option in auto standard that we would pull those field clearances from. So this field clearance information is used when our connection type is set to shear, okay, something other than auto standard. Next we have design criteria. There's two options in here that I want to take a look at that concern our shear plates. So the two options we have here, the design non-AISC options, just two little check boxes here. What these are going to do, the first one there, design non-AISC single plate shear connections. In our AISC books, it specifies that either the beam web or the shear plate thickness to be less than or equal to half the bolt diameter used plus a 1/16 of an inch. So as long as this option is not checked, SDS2 Connect is going to follow that guideline. If we want to ignore that guideline, we can go ahead and turn that option on, and it will ignore that guideline for us then. And the next option is similar to that. So the AISC specifies the weld size for single plate shear connections is to be sized as 5/8 times the plate thickness. Again, leaving this unchecked will follow that rule and size your welds to be 5/8 times the plate thickness. Otherwise, it goes ahead and ignores that rule. Okay, I believe that option or that rule actually changed between the LRFD 3rd and when the 13th edition came out. It used to be, I believe, 75% of the shear plate thickness was kind of the general rule. That's changed to be 5/8 now. So the next options to take a look at then are going to be under our standard fabricator connections. In here we have a section dedicated to shear plates. And first options we have in there are going to be vertical and horizontal edge distance. So for the vertical edge distance, SDS2 Connect should follow table J3.4, and it's going to use the values for the at-sheared edges for the vertical edge distance. We're just simply setting a minimum there is what we're setting. And then the horizontal edge distance, in that case we should follow 2 times the bolt diameter as a general rule for the horizontal edge distance. And again, that's something that's specified in the AISC book. So the minimum thickness option that we have in here, this is only going to apply to splice plates or moment shear plates. Okay, if you remember, in the schedule of minimums that we just talked about, we actually are setting the minimum thickness for single plate shear connections. So that's just a shear plate connection, no moment, no nothing applied to it. That minimum thickness is coming from here. For our, like I said, moment shear plate, minimum thickness is going to be taken from here. Next we have the standard hole type, so we can specify which hole type we want to be used in our shear plates. Non-combined vertical brace hole type, so if we are framing a brace underneath and at a beam to column intersection, what do we want the hole type in the shear plate connecting the gusset? Do we just want to match what's used for the beam, or do we want to specifically say a standard round, short slot, etc. there? Shear plate alignment, there's 2 options here. That's going to affect how SDS2 Connect determines which side of your beam web to actually place the shear plates. Keep shear plate symmetrical. Basically all that does is it's going to actually center the holes on the plate so that the plate is symmetrical about the holes. The next 2 options here, to cope on connections that extend past flange and cope extended shear tabs to reduce beam cope. These 2 options are either going to cope the shear plate when it's extended past the flange of the supporting member, or when you size it to extend to the like the K distance or the bottom flange or the top flange of a supporting beam. And I'm just going to go ahead and show you in our help menu exactly what that does. If I get it to come up here. Okay, there we go. So just kind of, I don't know if many of you have actually seen our help menus or whatnot yet. So I'm just going to go in here, pretty easy to browse to exactly where I'm at this point. And then it should come up with that window with the options that we see over here. Each one of those is a link. I can go ahead and click on it. We typically provide pretty good pictures and whatnot for everybody to see. So lot easier to see what's going on here rather than just listening to me the entire time. So here's our two cope options. If we have that turned on and we're extending past the flange, SDS2 Connect can cope that shear plate, which reduces the beam cope. And same with the option to cope extended shear tabs to reduce beam cope. We could choose to cope our shear plate out a little bit, which in turn again reduces the size of the cope needed in the beam. Okay. The next option there, extend connection and cut flange flush. If we have that turned on, that's going to allow SDS to connect when it's designing these shear plate connections to go ahead and cut the bottom flange flush with the web. That'll may allow in some cases then to get a extra row of bolts in the connection, and that may be the determining factor sometimes between a failed connection and a actual design connection like we see here. So if we don't have that option on, we're not going to allow it to cut that flange flush, and sometimes we may not be able to fit the required rows of bolts in there then. Okay, final option there that we'll talk about, the combined beam and vertical brace shear tabs. So that is going, if that is turned on, that will allow SDS to connect to extend our shear plate either down to a brace gusset and share that with the brace gusset. If that brace were framing into the top in this picture rather than in the bottom, it would extend that up then also. With this option turned off, we're going to get two separate shear plates for the beam and for the brace gusset then. Okay, next options that we have are going to be in member detailing / fabrication options. So one option I want to mention in here is the member end edge distance. Okay, by default it's set to 1 3/4. So member end edge distance, that's just going to be the distance from the end of your member to the center of the first holes. Obviously, this is also going to have an effect on our shear plates also where the holes are located in that, so that's why I want to mention it here. I know I see a lot of users changing that to 1.5 to get that properly where they want it, so that's the reason why I wanted to show that one. And the last setup option that I'll mention then is in connection detailing fabrication options. In here, we have basically a big table here where we can set our bolt spacings. So we can have different bolt spacings for each bolt diameter. We have our imperial bolt diameters on the left here, and we're setting the bolt spacing there. Then you have your metric bolt diameters and set the spacing for those on the right side. Now, we can use these bolt spacings for only our shear plates, or if we pull the option down here to use bolt spacings for, we could choose to use that bolt spacing on all connections, including clip angles, end plates, etc. Okay, so now that we've seen pretty much all of the setup options that are going to affect our shear plates, now let's go ahead and just take a look at what we can do with our shear plates within the connection edit window. So I'm going to just go ahead and hit cancel on my setup window. I can close that help menu. And what I've done prior to this is I've actually set up all my auto standard connections to use a shear plate connection. So if we take a look at the connection into the column web that we have over here, you'll notice we have a shear plate. The other thing that you'll probably notice is at the bottom flange of our beam, okay, we notice that that bottom flange is coped out a little bit, okay? So just another bit of an example of how SDS2 Connect, when it designs connections, takes into account erection, erectability, that sort of thing. So with this shear plate, actually it would be shop attached to the column web, to be able to erect that, then we cope out that bottom flange and it can slide right down in the beam web there between the flanges to get that erected. If I go ahead and edit this connection, okay, first thing just to point out here, I do have this set to auto standard. I want to take a look at connection specifications. Okay, some of you may be familiar with this already, others may not. When I go into connection specifications, currently you'll notice it tells us that these do not apply to an auto standard connection. So what I may do, come out here to my connection type, set my connection to shear, and now I have different options to make modifications to my shear tab. Our material type, currently we don't actually support WT connection material, so even if by switching that to WT, it's not going to do anything for me at this time. So plate is all we do currently. You have your plate grade that you want to be used. Another option here, attach the T or plate to. Okay, we're talking about how do we want that to be attached in the shop to either the supported or supporting member. So if I set that to supported, going back to talking about that beam cope, okay, now if this is shop bolted to the supported member, which is the beam, we don't actually need that cope in the bottom flange then to erect that, and it goes ahead and redesigns that connection, taking that into account. Okay, go back in here and take a look. Our shear T-plate side, so we have control over which side of your beam web that this plate is on. Currently, if I take a look, move this out of the way, that should be on the near side. Okay, so if I set that to far side, it's going to go ahead and flip the side of my beam web that connection is on. Go ahead and edit that again. And support condition, we have a flexible or rigid support condition. The option to extend past flange, now that is going to work when we are framing into a column web. It'll pull that beam out past the column flanges. We can also use that option if we have a beam-to-beam situation here. So again, to change my connection specifications on a case-by-case basis, I can set that to shear, go into connection specifications, and check that same option there to extend past flange. Should do similar to what it did there in the column web. Remember, your connection specifications are also in the auto standard setup, so you can set up your auto standard connections to do all these same things by checking the right options in there. I'm going to turn off extend past flange just to show you another option here. I want to show you the stiffener opposite option. Now when I turn on stiffener opposite, this should create a stiffener on the opposite side of the beam web that I am framing to here. However, this only works if I have the extend plate size 2 option right below there set to something other than as required. So if I want that stiffener, I'm going to go ahead and say extend that to, I'll just say top flange. Okay. When SDS2 Connect designs this connection, then it goes ahead, extends my shear plate to the top flange of my supporting beam, and the stiffener on the opposite side that it creates will always match the depth of the shear plate that is designed. Okay. Another option I have in there, try 2 bolt column shear tabs. If I turn that on, I should get 2 bolt columns. So you see we have 4 bolts. We have 2 rows, 2 columns now rather than just 2 rows to get extra bolts in there. Other things we can do here with our shear plates, if I move over here just to show you, a lot of people are always asking about through shear plates and can we connect to tubes and all of that. Yes, we do connect to tubes, so we can see I have that in this model here. And I'm going to go ahead and edit these connections here, kind of just to show you what we can do with the shear tabs then in that case. Again, remember, I'm going to set that to shear so I can go into my connection specifications, and I just have the option for a through shear plate. Simple enough, check that. And it's going to design that going through my tube column then. Okay. Right now you'll notice we have two separate shear plates for the beams framing on opposite sides of my tube. If I go ahead and edit the shear plate then on the opposite end, opposite side of the tube, and I check the option for through shear plate here, we should get one single shear plate then that is shared between those two. I could take it just one step further if I edit the connection framing perpendicular to that one and do the same thing. We should, SDS2 Connect should recognize all of that, and it's not going to actually run that plate all the way through, so we see we get it to basically butt up next to the other one there. Okay. Just to mention here a couple other options real quick and then we'll open it up to questions. One big one that I do want to show is the combined plates option. So that has to do with the combining of vertical brace and beam shear plates like we showed you earlier in the setup. This is just a way to override that. So, you know, I showed you all the setup options. You kind of want to keep in mind, though, setup is just basically general guidelines that you want your connections to follow, and then on a case-by-case basis, you can make changes to things to each connection through the edit window. So that's kind of all I have here for you today for the shear plate connections. I'm going to go ahead and open it up to questions here. We have a little bit of time yet, and like I said, if we go over the time, no problem. So any questions you guys might have concerning can be related to what we've seen here with shear plates or just anything SDS2 Connect. If you want to go ahead and type that over in the questions pane on the webinar toolbar, we can go ahead and do that. So we do have one question here already. Quick question. Someone asked, how do I select whether or not bolts are modeled? So the answer to that, there's actually kind of two parts to that. So the first part is if we go into our options, we actually have an option in there to generate connections with bolts. If we turn that off, SDS2 Connect is not going to generate the physical bolts in the model. It takes them into account during connection design, you know, figures out how many rows and everything you need. They're just not physically displayed in the model if this option is turned off. The other part to that then is the bolts are actually only displayed in a with your fine resolution. So if I change that resolution to medium, my bolts are not displayed in the medium or the coarse resolution. So they're only displayed in the fine resolution. Okay. Couple other questions here. One is, can we see a sample of the design calculations produced? So if we want to take a look just quick, I'll show you here with the extend past flange calculations. I'm going to go up to my report command, pick my connection that I want those to be shown for. I get my printout here with just general information, have my limit states here, and if I click View Extended Report in Firefox, then we're going to actually get the, down below, we're going to actually get all the formulas and how we actually arrived at the results that we did then. So we get all the longhand information there. Okay. So another question that has come up here is someone is asking, if I make a change in any of the shear plate settings, do I have to make the same changes and setup in SDS2 as well? So sounds like you're, in this case, concerned with transferring models from Revit into SDS2, probably concerned with if settings are being changed here that they match in SDS2. You could go ahead and make the changes in both Revit and SDS2 yourself, or when we transfer the models, or when you transfer the model to SDS2, all the setup information is actually transferred also. So as that gets transferred, when you import into SDS2, we go ahead and update the all the setup settings to match them. So we shouldn't have to worry in that case when we're transferring models that our setup is going to be different. Another question we have here is, can a bolt quantity be calculating using Revit? This is something, honestly, that is keeps coming up quite a bit. It's a pretty popular question here. Currently, the way that we have this set up, it's pretty difficult to get and actually it's really not usable to get a bolt quantity or like a total bolt quantity calculated out of Revit. It is something that I think we're looking at here to make a few changes, possibly add a couple things so that people can get bolt quantities and whatnot out of it. So. Another question about the bolts. So someone is asking if the bolts are turned off at the beginning of a project, can they be turned back on later and have them all generate automatically? That should be no problem. If you have them turned off at the beginning of the project, you decide you want to turn those on. I believe what you're going to have to do is, once you turn that option back on, you might just want to come up here and hit the design all. So that's going to go through and, that's going to go through and design all the connections. It needs to do that so it can basically generate all that information then. So should be all right, like I said, as long as you come back up there and hit design all. So another question here is concerning shear tabs that have a shear load plus an axial load. So if I want to look at something like that, if I edit my connection, just to kind of show you here, I'll go ahead and add a tension load. I'm just going to throw in 10 kips. Now, when I do that, you notice I get a failed message down here at the bottom. Tells me slip critical bolts are required for slots or oversized holes. So since my default hole type to be used with shear plates was a short slot, slip critical bolts are required. I can actually go ahead and come up here to my non-moment bolt type, change that to A325 slip critical. A few more things that I'm running into here: required bolt diameter greater than the maximum. I'm going to cheat a little bit here just so we can get a connection and show you here. I'm going to drop my shear load down a little bit. Okay, so then it goes ahead, redesigns that connection. Again, you can go ahead and take a look at the design calculations. I'll just bring them up here real quick, just to show you we are still doing all of that. We are getting the design calculations done for you here. Okay, another question: will SDS2 connect design connections per AISC 34105 seismic provisions? We really don't have a lot of the seismic design incorporated yet. That is what we're planning on doing here in the future. Some more seismic design is one of the many things that are on the list of kind of enhancements that we need to make. So fairly limited currently in what we do with the seismic design. Like I said, it is on the list for enhancements. So another question then, is design link required to transfer from Revit to SDS2? The answer to that one would be no. If you're using the round tripping included with this, which we see up on the toolbar here, you can actually import and export the models using basically the same functions in SDS2. It's actually found under your model pull down, and then there's a Revit section. Okay? That is only available in SDS2 versions 7.243 and higher. So anything lower than that version, it's not actually available in. So another question then is, are fillet welds shown / modeled? Currently we do not do any welds. Excuse me, I shouldn't say we don't do any welds. We do not actually display or generate those in the model. They are taken into account, again, during connection design. We look at all the welds, size the welds. You should be able to see the size of the welds in the design calculations. You should also be able to see the size of the welds when I edit these connections. If you go into design details and you want to make changes in here, typically you're going to see weld sizes and whatnot, so we can see our weld size in here. Could make changes to it if we wanted to and whatnot. So that was kind of something that we decided early on not to do. The big reason we decided not to do it is because of performance within Revit. If we were to design and generate and display all of those welds in the model, that Revit model would probably become almost useless. It would slow it down that much. So something we decided to not display and generate at this point. Okay. Another question here is, can you illustrate a truss connection? There's a lot of different connections that I've seen used in trusses. So just as a quick example here, I have a small truss that I've actually created in this model. So really all I've done here is the two top chords, the top and bottom chord, I just modeled those as beams. I modeled the web members then using vertical bracing, and currently what's being generated or designed for connections are just our typical vertical brace connections that SDS2 Connect is capable of. So that is kind of what we can do at this point. The truss connections that we're going to be capable of really are limited to what we do in the vertical bracing connections. One last question that we'll take here is, are holes in connecting members modeled? Again, holes are something that we chose to leave out at this time. It's same thing with the welds, is just the performance issues that we have with Revit in actually displaying all of that. We chose to leave those out at this time. So, but again, during connection design, we're looking at, the hole size, what type of holes they are. As you saw in that shear plate connection earlier, it was telling me that slip critical bolts were required in that situation. That's because of the standard or the short slot holes that were being looked at rather than just a standard round hole. So again, we take them into account, just do not display them. So, okay. Didn't go quite as long as I thought I would today. That's all right. But this kind of concludes everything for today. If anybody has any other questions that come up, feel free to email myself here or sales or anybody else that you've been in contact with. I'd be happy to answer any questions that you guys might have in the future then or that come up later. So thank you, and everybody have a good day.